Well, hello, class, and happy Monday. We've made it through our first week, and now we're going to move into our second week of remote learning. So, what I would like to do today is we've finished chapter 11 for the most part. But today I just want to do some practice problems as we talk about compounding interest. We're going to talk about lump sums. That's what we have been talking about, is lump sum investing for compounding interest. So how much lump sum, how much do I need to put away now, the present value, in order to have a future value? Or if I want a future value, how much lump sum do I need to put away now, present value? So we talked about future value formulas and present value formulas. But as I used as an example previously, if I wanted to put away money now to replace my roof, let's say in 10 years, I would assume a cost, and then that would, using the present value formula, I could determine how much do I need to put away now. But one of the things that we have to take into consideration is that a lot of times people use the current values, the current costs. If I were replacing my roof and I got a bid from somebody and they said, yeah, it's going to cost you 10 grand to replace your roof, and I use that as my future value, how much money I need, that's not taking into account this idea of inflation. And inflation is that everything goes up in price. Dollars and cents, a little note here. Inflation should be taken into account when making financial plans that cover time periods longer than a year. So if I'm talking about replacing my roof in 10 years, I have to take into account inflation, okay? And so inflation can be handled using these compounding formulas. And we're going to go through an example here and show that. So here's a finance manager. This is on page 360 in your books, if you have them. And it's the business decision, and it's called the inflation factor. All right, the problem reads, you are a finance manager for Olympia Industries. The company plans to purchase $1 million in new assembly line machinery in 5 years. So that is a future value, $1 million in the future. How much must be set aside now? If it's asking for what is now, that has to be present value. So we're going to use the present value formula to figure this out. How much must be set aside now at 6% interest compounded semi-annually to accumulate $1 million in 5 years? All right. So we know we're going to use our present value formula. Present value equals a future value. They call that the compounding amount. I'm going to use future value all over 1 plus small I, which is the interest rate per compounding period, all raised to the exponent n. And n is the total number of compounding periods in my problem. All right? So we know that the future value equals $1 million. All right? And we know that it is compounded, I believe, semi-annually, so that's twice a year. So semi-annual. They also know it's 5 years. All right. So if I know that much, I know that, oh, and it's at 6%. All right. So 6% is my nominal rate. So if it's semi-annually, I know that n is going to be 5 years times 2, which is 10. So n equals 2. I know that I is going to be 6% divided by, if it's semi-annual, twice a year. So the compounding interest rate per period is 3%. All right. So now I'm going to fill in my formula here. The present value equals the future value, which is $1 million, all over, and I'm using the formulas here, so it's all over 1, I keep putting the plus, 1 plus 3%, 0.03, all raised to the n 10th. So that equals $1 million, all over 1.03 raised to the 10th power. All right, so let's do a little calculator math here. 1.03 raised to the 10th power. All right, that's $1 million. 1, 2, 3, 4, 5, one more. All over 1.343916379. And as many places as you can use, as many places as your calculator gives, either save it as memory in your calculator for this particular formula because we're dividing, so it's going to be the numerator divided by the denominator. So if you're writing it down, get as many decimal places or save it in your calculator. All right, so now we're going to take 1,000,000 and divide that by 1.343916,379, and that should give us the present value of 744,093.914. The next value is 4, so that I will not round up. I'll leave it the same. So $744,000 would be the present value, and this is A. All right. So I would need to invest $744,000 to get myself $1 million at 5 years, compounded semi-annually. Okay. Now the next question: if the inflation rate of this type of equipment is 4% per year, what will be the cost of the equipment in 5 years adjusted for inflation? So we're saying, hey, we need $1 million. Eventually, we're going to need $1 million, but that's what the cost of the equipment is now. But if the inflation rate is 4% a year, well, that's compounding because it's going to be interest on top of interest. After 1 year, 4% would give us 1,040,000, and then the next year 4% of that, so on and so forth. So this is compounded. So we got to figure out the inflation rate. So we need to figure out the future value. What is it going to be worth if it's inflation of 4% a year? So future value equals the present value, 1,000,000, all right, times 1 plus I raised to the n power. We already know what I is. All right, actually we don't because this is inflation. That was the investment. So inflation is 4% per year. All right. So it's not compounded. This is just per year. So the compounding period would be 4% divided by how often it's compounded. That's once. So it's 4%. So that's what I equals. All right. How many compounding periods? 4 years, once per year. So n is 4. So my future value equals 1,000,000 times 1. I did it again. 1 plus I, which we said is 4%, raised to the n. So that equals 1,000,000 times 1.04 raised to the 4th power. All right, so 1.04 raised to the 4th power equals, so that's going to be 1,000,000 times 1.1698586. It looks like it repeats. All right. So I'm just keeping all the factors. So if it's already in your calculator, now multiply that by 1,000,000. All right. And so the future value is going to equal 1,169,858. Goodness, I got to make sure I keep this in the window. Sorry. All right. So you can see here 1.04 to the 4th power, 1.1698586 equals. All right. So in the future, it's going to be worth 1.169858 million and 56 cents. Okay. So we know that really this is what we need to save now. Not the million, but to take into account inflation, we got to save this. So C then asks us, use the inflation adjusted cost of the equipment to calculate how much must be set aside now. So now we need to know what our present value is if our future value the future value equals $1,169,858.56. at the same savings vehicles that we were talking about before. So 5 years, 6% compounded semi-annually. All right, so I can use the I and the N from up here. N is 10, I is 3%. So now I can fill it in and say, okay, this formula should be, the future value is 1,169,858.56 all over 1 plus the I being 3%, and the N is 10. So 3% raised to the 10th power. All right, so with that, we know that that's 1,169,858.56 all over 1.03 raised to the 10th. All right, and so that should equal 69858.56 all over. So 1.03 raised to the 10th. All right, and we already saw that that's 1.343916379. All right, so now if we do that math, our present value that we would have to invest now would be 1,169,858.56. All right, divided by 1.343916379 should give us, all right, $484.64. It's 635, so that 3 rounds up to 4. So really, this is what we should invest now to give us $1,169,000 because of inflation. So that adjusts how much we have to put away. That's over $100,000 more. All right, so that makes a difference taking account inflation. All right, the last thing has used the present value formula to calculate how much would be required now if you found a bank that offered 6% compounded daily. All right, we already know, we've talked about this earlier, that the more compounding periods there are, the better the interest earned, the higher the interest will be. So if we find a bank that says, hey, we will give you more money. Okay, so if we use the present value formula out, how much do we have to put away? If our I and our N change, then we will be good. We will disregard, if it's compounded daily, we'll use the 365, and we'll disregard leap years. We'll just do 365, all right? So again, we're going to use the present value formula, the future value of what we need, the 1.169 million, over 1 plus I to the N. Now in this case, I is going to equal 6%. The interest rate didn't change, but the compounding periods did. How many compounding periods are there? 365. Divided by 365 equals... Did I do that correctly? 0.06 divided by 365. Yeah, so it's going to be 0.1643835562. Oops, that's the point is here. There we go. All right, so that percentage, that's way, so the percentage is going to be boom, boom, 0.00016. I just did this as a percentage. All right, so if I do it as a decimal, 0.06 divided by 365. All right, 0.06 divided by 365. 0.0. I keep punching the wrong things in the calculator. 365 should equal, all right, to the minus 4. So that would equal 0.000164385 and so on. All right. So that is the interest rate. That's our I. So it's really small. All right. And we know that because we're doing it daily. Now our n, if we're doing it for 5 years times 365, that's how many periods in a year. 365 times 5 gives us 1,825. All right, so this really is changing it. So present value equals our future value, 1,169,858.56. That's what we found in C, no, or in B. Okay. All over 1 plus I, which is 365. No, it's 0.000164385. All right, raised to the 1,825, which equals, all right, so we're going to say 1 plus 0.00016438561 equals, all raised to the 1,825th power. All right, so that ends up being all together on the bottom here. So that's 1,169,858.56 divided by 1 plus, or actually 1.349825526. All right, so now we're going to take our future value, 1,169,858.56, divide that by what we just got. All right, so now that should give us 8666673.905, 3, which is 91. All right, so now because we didn't change interest rate, we just went from semi-annually to daily. We've dropped it by we dropped how much we have to put in now by $4,000. So I'd rather save $4,000 now. Instead of 870,000, we need 866. All right. So we saved $4,000 by compounding daily. Didn't even change the interest rate. That stayed the same. We just compounded daily instead. Okay. So that saved us $4,000 now. All right. So we got to take the inflation seriously as we consider this, and we have to consider what are our best savings vehicles. Okay. What I would like to do now is I'd like you to practice inflation. All right. So if you would turn to pages, we're going to turn to, in your books here, I went one page too far, I think. Yep. So on page 365, okay, I want you to look at problem 20. All right. Now it says here in the book to use tables. Just use the present and future value formulas. But it says you are the owner of Janie King, janitor. All right, Janie King Cleaning Service franchise. Your account has determined that the business will need $27,500 in new equipment in 3 years. If your bank is paying 6% interest compounded monthly, how much will you need to invest today? All right. So figure that out. How much do you need to invest today? But then assume 3% inflation per year for 3 years. Find out the new future value and determine how much you need to put away now. All right. So what I want you to do is to figure out on 3% inflation over 3 years. All right. So figure out the lump sum now, the present value now. For $27,500. At the prevailing rates they give you, and then figure a new future value with 3% inflation. Okay? So go ahead and do that now, practice that, and then I'll come back with the answers.